So this is where we were yesterday. That's that. You may recall, I don't know if you ever watched the videos I've posted up, but the video yesterday was quite long. I trimmed it down to about 8 minutes because I got that extension question 2 wrong. I thought, Ibrahim, there was a mistake in the angles. There really was not. So let me go over it real quick. Not sure what question that is, but it's part of question 1, I think. So if you look at it carefully, I've got 10 divided by 4 as corresponding sides is 2.5 times enlargement. 15 divided by 6 is 2.5. The angles match as well. They are similar shapes for sure. Next one, this was quite easy actually, but this was a bit of a con. 7 divided by 4 is 1.75. 10.5 divided by 6 is 1.75, but the angles don't actually match. If you do alternate angles and extend the angle outside, for example, corresponding angles, if that's 108, that must be 72, which means this guy in the corner is also 72. Let me just enlarge it. That's even better. So if that is 108, the exterior angle is 72, so that is 72, which does not match that 76. So whilst in terms of enlargement of the sides there is agreement, the angles don't agree, and the angles must be the same. Yeah? When you enlarge a shape, when you did the diagrams on a grid with dotted lines as construction lines, all the angles were the same. It's the lengths are in the same ratio. Trouble is, those angles don't match. And if that's 76, that's going to be 104. So that's no good, is it? Then there's this one, which is dead easy. Notice they do the trapezia upside down just to confuse our lives. It's quite easy to see that that 9 matches that 3 right there. We've got 9 over 3, enlargement of 3. And here we've got this 15 divided by his corresponding smaller 5 comes to 3, similar, and all the angles match really well as well. Bring this down a little bit. Next page. This is the one I wanted to redo. In fact, I've redone it from last year. I'm told they are all similar. So if you're 87, let's change to a nice bright colour. If you're 87, then you are 87, no question. And you, X, are also 87, no question. And if I can just spin you round the right way, the 6 goes with that 3 right there. I can see a ×2 scale factor enlargement, and there's my working. So all I need to do is to take one of my 4s, times it by 2, and get my 8. Got it? That works. So B is 8. Now I've got to work with the C. Well, this 3 matches that 9 right there. So from this shape to this big shape, it's a ×3 scale factor enlargement. So if I multiply my 3 by 3, I get 9. If I multiply by 4 by 3, I'll get 12. And that takes care of that one. This is a bit too thin, I think. Get a little bit bigger. Now over here, I've got to work out missing sides. Well, the only thing I've got to work with is that 6 and this mystery A. Well, I can see that the 3 and 6, the corresponding sides or the matching sides, are in a scale factor of 2. So if I take my 6 and divide by 2, I get A is 3. Now we agreed this was a pentagon, and if that's 143, that's 90, that's 90, that's 87 because he says so. And I add all that up, I get 410, as Tyne agreed with me yesterday. When you subtract that from 540, I get 130. So here's the mysterious thing that really threw me. That really is 130 degrees, which matches that. That really is 143 degrees, which matches that. Not that it asks me to find it, but it's true, because if you add up 30, 87, 2 90s, 143, you will get 540 degrees. Absolutely you will. So I now got it right eventually, and it probably agrees what's in the answer book unless the answer book is wrong. But that's it. That's why I shortened the video, because of him. Anything to ask about that at all? It's complicated. You went from easy questions straight to bang, this horrible thing here. But there it is. That's why it works. Remember guys, I'm doing the video for your benefit. If you need to go back and take notes, what you do is, when I put the video up, which could be a little bit later, because I've got other lessons, I've got 2 more lessons, then you can take notes on this. You can supplement what you've got. Remember Henry, remember everyone, you've got to show your steps. These are your marks. These are what get your marks, yeah? Not just bang, the answer Z is, 130 because I say so. Well, prove it, work it out. Let me turn over for today's lesson. So this is taken from your book. I did a photo with my camera right here, and this is quite easy. For each of the following, decide whether the 2 triangles are similar or not. Well, you match, don't you? You're good. No, sorry, 88, 87, 83, 38. You don't have to draw this. If you can take a photo of it like Neha does and stick it in your book, also that's what Hamza does as well. You just have to write, are they similar? No, because not all of the angles match. Done. Let's do B together. So somebody talk me through this one. I need to prove one way or the other to see if these are similar. What do you reckon? Someone want to talk me through that? Or a step? I don't mind. So who can we ask? Henry's bold. A lot of you are shy. Ibrahim, are you here? Well, you were here. Very good. Would you like to talk us through a step for this? Or multiple steps? So I want to decide whether these 2 triangles are similar or not. Any ideas? Ibrahim, we've done this one. Yeah? I'm doing B now. Yeah. Okay. And therefore similar. So here's this is the way you should set it out, actually, because you gave me a paragraph of English words. How about 6 divided by 4 equals 1.5? No point doing that one as well, it's 2 of the same. And how about 12 divided by 8 equals 1.5? Therefore similar. So we have to do. You don't need to score 3 out of 3 because these 2 are the same as these 2 in terms of a match. It's if you've got 3 different lengths, you've got to do that. And the angles don't matter, because for this to be a scale factor larger than 1.5 means that these angles must automatically be the correct angles that they should be. When you're in larger shape, remember, the angles don't change. So this is, I'm trying to give it 3 little ticks there. There you go. So these are the matching angles, and they will match automatically. You can construct these triangles. If you were to construct it and measure the angles, you'll find they'll be exactly the same. So that would be that, for example. So that's that one. And this is question 2. Clearly don't draw this. So Brandon, I'm letting you off, etc. I'm letting you off. But, a photo cut out, stuck in, will be perfect. It says that these pairs of triangles actually are similar, so you have to obey that, which is helpful. Find the missing angles and find the missing lengths. You can write the answers straight on the diagrams if you want to, if your diagrams are big and spaced out, or you can just write down A equals B equals, I don't mind that because it's a lot to draw. So these are similar triangles. How big is X? Anyone can call out. How big is angle X? That question goes to Neha. 98. Absolutely, because all the angles remain the same. How big is angle B? Sorry, how big is length B? That goes to anyone else. That goes to Suban. How big is length B? 10 centimeters. Clearly, because from 6 up to 12, we're multiplying by 2. So it's a times 2 enlargement. And therefore, how big is A? That goes to MF. It's half of the 6. Okay, and that's all you need to do. You don't have to show arrows. If you get the answers right, I trust that you've either done this in your head or grabbed a machine. It doesn't matter. I want to do C because it looks ugly because there's decimals and stuff and it's terrifying. Which length corresponds to the 3 on the big shape? That question goes to human being, Hamza. Okay, so this next question goes to Faz. How do you establish a scale factor enlargement? The man's clever. Yep, divided by 3. Now that's terrifying. I want to call that 45 over 30. Oh, I can see that's 3 over 2, just about. I can see that's 1.5 or 1.5. So if I want to work out B, for example, I'm going to take my 4, multiply by 1.5 and get a 6. If I want to work out my A, I want to take my 7.5 and divide by 1.5 to take me down to 5, I think. Yeah, 5. And that's it. That's all we need to do. If you want to show you working around the pictures, be my guest. That's absolutely fine. You've done well if you've done that. But it's really cramped and really messy. If you want to show it underneath your printed page, I'll be very happy with that either. Some of you, and this is some of you, ought to try question 3. I've called it EXT, and I've also put it in the and show my homework as part of what you need to do. So we do question 1, question 2, and question 3. You don't need to be too brave, but don't look at it and say, I don't need to do this. Maybe Henry, you do it. Maybe Neha, you do it because you like it. Easy. If you've not already done it, do it. That's it. So thank you to Faz for sending me his work. But Faz, some of it's son, I couldn't read it because it's blurry. The rest of it looked really, really good. So if you need to resend me anything so I can judge it and send you some feedback, I can do that. And I'm really looking forward to question 3. So I want to call that done, I think. And stop that.